Let's talk about linearization. Linearization is the process of converting a non-linear equation into a linear equation such that its graph will now be a straight line graph. The first thing you want to be familiar with is the form at which we have a straight line graph, at which we have a linear equation. In slope-intercept form, a linear equation will be expressed in this form: capital Y equals m capital X plus C, where each of these letters has their corresponding meaning. The capital Y stands for the dependent variable, that is, it depends on the value of X, the value of M, likewise the value of C. The lowercase m stands for the slope, sometimes known as gradient, and the value of X, capital X, stands for the independent variable. It doesn't depend on neither Y nor M and C for its value to be determined. Then the last one is that of C. C is the intercept along the dependent variable axis. Intercept along the y-axis. So note this down as we will be using them as we proceed forward. Now, how do you want to deal with problems involving the process of converting a non-linear equation into a linear equation? What you just need to keep in mind, your main goal is just to re-express that given equation all the way to the form of y equals mx plus c, and that's all. So let's consider an equation lowercase y equals ax squared plus b, and you are required to determine or convert this equation into a linear. First, what makes it not to be a linear, and how do you want to know when you are having a linear and non-linear equation? For a linear equation, the degree of both the dependent and the independent will be 1. It must not be more than anything rather than 1. Secondly, there must be intercept C. Then thirdly, the dependent and the independent must not be associated together. These are the 3 factors that you need to always work with whenever you are dealing with problems involving linear equations. Now, first and foremost, you can clearly see that this equation is absolutely not linear. Why? Because one of the factors has been altered. The independent variable is to the degree of 2. So how can we convert it to a linear? In this case, all we need to do is just to change the axis. The axis is y, lowercase y, and lowercase x. So what I will do now is that we are just going to say let uppercase y be equals to lowercase y, and uppercase x be equals to x squared itself, lowercase x squared. Now with this, we can clearly see that the equation will turns out to become uppercase y equals a uppercase x plus b. Now at this point, you can clearly see that the equation is now in this form. Oops. And the slope will be the value you observe to be associated with the uppercase x. So the slope m will be equals to a, and the intercept c will be equals to b. And that is our final answer for that problem. Hopefully you got that. Let's consider more in order to understand this process to a higher level. Hopefully you have written that. Now consider this one. Y, lowercase y, equals a divided by x squared plus b. This is not a linear equation. Why is it not a linear equation? Because the independent variable x is raised to the power of 2, and at the same time, it is not a whole number, it's having like a fraction. So what should we do? Now let's just re-express this by using some of our knowledge in algebra. This can become a multiplied by x raised to the power of negative 2 plus b. Hopefully you got that. What I did was that I changed a over x squared all the way to a times 1 over x squared. And 1 over x squared is the same as x raised to the power of negative half. Okay? Good. Now, let's try to change the axis. So we can by the way, you can use any other variable. It's just to like re-express it such that if we graph it, it will produce a straight line. So our new axis capital Y will be equals to the lowercase y, and our new axis capital X will be equals to x raised to the power of negative 2. And with this equation right here will turns out to be written as y equals a capital X plus b, whereby its slope, lowercase m, will now be equals to a, and its intercept along the capital Y axis will now be equals to b. And this is our final answer. By now, you should have been getting familiar, you should be getting used to the process. Let's consider one more. By the way, if you haven't subscribed to my channel, please do subscribe to my channel. Also, feel free to pause the video and check this question out yourself. Y equals a divided by x plus b. Pause the video and figure this out. So what should we do in the first place? Well, what I would suggest is that let's take the reciprocal of y. If y equals this, then 1 over y will be equals to flipping this fraction, x plus b, all divided by a. Some of you might be wondering how that is possible. So here's the way we can show it out. Let's cross multiply in the first place. If we cross multiply, we can clearly see that it will be equals to y multiplied by x plus b, and that's going to be equals to a. Since our main goal is just to turn it to something like this, then what I will do is to divide both sides by y. And again, I will divide both sides by a. Dividing this by a, that's going to be multiplied by 1 over a. Then multiplied by 1 over a. At this point, we can clearly see that this will cancel out, and this will cancel out. And finally, we should have x plus b over a to be equals to 1 divided by y. And let's see. Now you now know how we get that. Now at this point, we can distribute the denominator. So we can see that 1 over y will be equals to x over a plus b over a. Now we have constants, and we have been able to separate the independent variable from the constants. The key idea whenever the given equation is not in the form of y equals mx plus b or plus c, whenever it's not in this form, the key idea is to rearrange it in such a way that you will have a constant first. Okay, that will be the key idea, and that's what we are trying to do. And now we have a constant. So let's try to make some substitutions. So 1 over y, the reciprocal of the dependent variable, 1 over y, we can say that will be equals to the bigger y, and the uppercase x should be equals to the lowercase x. We are not replacing anything, let it be equal to this like that. So eventually it will now be y equals 1 over a multiplied by uppercase x plus b over a. And this is our final answer. So the gradient will be 1 over a, and the intercept will be b over a. And that's it. I hope you got that. Let's consider one more for easy understanding. I just want you to grab the concept to the higher level. So consider this one. Y equals a root x over b. How can we write this non-linear equation into a linear equation? You can clearly see that we didn't have it in this form anyway. So our main goal is to write it in this form. So first, let's try to square both sides. So squaring both sides, we can have it to be this. So y squared, now we just need to distribute the square. So the first square will affect a to become a squared. And the second one will open the square root and have x over b. Now multiplying that, we can clearly have y squared equals a squared x over b. So there is no intercept, or we didn't have a constant. So therefore, we can make a substitution direct at this point. So uppercase y in this case will be indeed equals to y squared. And uppercase x will be equals to lowercase x. And finally, uppercase y will be equals to a squared over b multiplied by uppercase x without intercept. This is possible. So therefore, the slope will just be a squared over b. And that's the answer. So in case you ask, what is the intercept in this case? So what I just said, is that it is simply 0. Intercept is 0. There are some straight line graphs that when we graph them, they are going to touch the y-axis at the origin. Such kind of equation or such kind of graph will have the equation to be in this form without intercept, because the intercept is 0. Hopefully you got that. Now, there are some scenarios whereby you won't be allowed to make a substitution. You won't be allowed to change the axis at which the graphs will be plotted. It will be mandatory for you to rearrange the given equation without changing those independent and independent variables for your answer to be gotten. In this case, what would you do? First, what am I saying next sense? Consider this statement. Write a suitable functions for P and Q, which could be plotted against each other so as to obtain a straight line graph. So the first function is Q, uppercase Q, equals AP, uppercase P, raised to the power of n. So this is the function. How can we rewrite or re-express this function such that it will be in this form? Y equals mx plus c. Note, we are not allowed to change the axis. We are not to substitute Q and P for Y or any other thing. If we did that, then our answer will be considered wrong. So what should we do? When you have a problem like this, your main goal is to rewrite that expression in such a way that you will have a constant C. Once you have that, then you have no other problem. The secondly that I will recommend is that make sure that those variables, both the independent and independent, make sure that their index is 1. Like this now, the index is n. We need to find a way to get rid of that n. And what we can do in this case for this kind of problem is to use the logarithm ideas. So let's introduce log to both sides. So the log of q will be equal to the log of ap raised to the power of n. So therefore the log of q, some of the properties of log, the log of two quantities multiplying themselves will result in the log of the sum of the individual quantity, a plus log of p raised to the n. Now another property of log is that when you have an exponent like this, the exponent can come to the front and multiply that logs. So that will be log of q equals log of a plus n times log of p. Now you can see that the index of the dependent variable q is 1 and the index of the independent variable p is also 1. At the same time, I now add a constant, which means I can stop at this point. Log of a, that's a constant value. So therefore, it's already in this form, where the y will be log of q, then x will be log of p, then c will be log of a. Now, what about n? What will be the value of n? That will just be the gradient. So, which means sometimes you might be asked to find the gradient and the intercept. So, lowercase m is just n, and the intercept c is log of a. And that is the solution to this problem. Let's consider more. Now, what about this one? Q equals AB raised to the power of P. Pause the video and try to write a suitable functions for this equation such that we will be able to plot it, and when we plot it, it will result in a straight line graph, because as it is, it won't give us a straight line graph. So unlike before, let's use the idea of logarithm. You know what I would just suggest, whenever that variable you are solving for involves exponents, you can always use the idea of logarithm in this case. But when there's too much of sum, too much of subtraction, it might not really work in that case, because logarithm properties usually used to work when you have index and product and divisions. You understand? So let's just logarithm. Log of q equals the log of ab to the power of p. Now, unlike before, let's try to split this. The log of two quantities to be multiplying themselves is typically the log of the sum of the individual quantities, b to the power of p. Now, let's use the index rule. So that will come to the front. So that will be the log of p or log of q equals log of a plus p multiplied by log of b. Now at this point, you can clearly see that we already have a constant. We have the dependent variable. We have the independent variable. But log of b is at the front of the independent variable. So what should we do? Well, you need to keep in mind 2 log of 3 is the same as log of 3 times 2, which means p log of b is the same as log of b times p. So we are still in the right place. Now this equation is of this form: y equals mx plus c, where y is log of q, c is log of a, m is log of b, and x is p. And that's it. And that is the solution to this problem as well. By now, you should have been getting the tactics. Like I said earlier, if you haven't subscribed, please do subscribe to my channel. Feel free to share the video with your colleagues that you also think will benefit from this video. So let's consider more complex problems. Consider this problem: q squared equals a multiplied by p squared minus b squared, all divided by p. How can we figure this out? Well, the first thing I will recommend, since we are not to substitute or change the axis and so on, let's first take p out as a common factor over here. Q squared equals, then taking p out, left over, and we have p here. But I need to balance this, so I will associate it with the division of p, so that by the time I expand the bracket, it will result in what it is initially, divided by p. So now at this point, we can clearly see that this will cancel out. Then now we have q squared equals a multiplied by p minus b squared over p. Don't forget, our main goal is to have a constant and make sure that the degree of both the independent and the dependent is 1, 1. Once we can do that, then we are good to go. Now at this point, since we have product and exponents, let's introduce logarithm to get rid of them. Though we are having subtraction, but that doesn't stop us from using logarithm. So taking the log of both sides, log of q squared will be equal to the log of a multiplied by p minus b squared over p. Now, applying the index law of logarithm, the 2 can come to the front. Then we can have 2 log of q. Then applying the product law, we can have log of a plus log of p minus b squared over p. Now let's divide both sides by 2 to keep things straightforward. Then log of q will be equal to 1/2 log of a plus 1/2 log of p minus b squared over p. Is this now in the form y equals mx plus c? Yes, it is, because now we have log of q to be equals to capital Y 1/2 log of a is equals to c, the constant, because a doesn't have any business with q and p in terms of variable. You understand? A is a constant. Then 1/2 itself is the slope, while the log of b squared over p is equals to x. You can see the p within the log are both in the first degree. Similarly, q is also in the first degree. So this makes sense. This is the general form in the straight line form of the given problem. Hopefully you got that. Let's consider one more. I like that question. Let's consider one more. Kindly subscribe to my channel if you haven't subscribed. Okay. Q is equals to AP plus B plus P squared. Now you can see that in this problem, there's more of addition, though there's product, there's index. But using log won't solve this problem, because taking log of both sides will be equals to log of AP plus B plus P squared. There's no properties that I can use to simplify this, so I will get stuck. So what should we do? In a case whereby you observe that using log property doesn't solve your problem, exponential property doesn't solve your problem, then what I would suggest is to use calculus. We can always use calculus to linearize a non-linear equations. And how does it work? You want to write that given equation as a function. A function is given as this: f of x to be equals to some expressions x, or some expressions in terms of x. For instance, x squared plus 2. This is a function. This f of x is the same as y. But y is the same as what? The dependent variable. We disclosed that earlier. But this capital Q is serving as the dependent variable over here in this problem. So definitely y is equals to q and q is equals to f of x. Perfect. Having done that, definitely p will be equals to x, because x will serve as the independent variable. And for the given problem, p is serving as the independent variable. So now, how does this work? Where are we going next? Here's how it works. First, let's write f of x. F of x will be equals to ax plus b plus x squared. What I did was that I've just replaced the value of p with x respectively. Now what says the linearization of f of x? L of x, which is the linearization form of f of x, is given as f of a, where a is a number, not this a that we have over here, plus f prime of a, the multiplied by x minus a. A is a number and not the a we are having over here. So don't mix them up. So what says f of a? In this case, we'll be using 0 as the value of a. F of a at a equals 0. Why did we need to use 0? Because using that will help us to get a constant. And don't forget, our main goal is to have a constant. So a multiplied by 0 plus b plus 0 squared. This results in b. Now we have a constant b. Similarly, we need f prime of 0. That is f prime of a. But a is equal to 0, so we need f prime of 0. First, what exactly is f prime? That is the first derivative of the function f of x. So what is f prime of x? To find the derivative, we just need to reduce the index of the independent variable one after the other and multiply by it. So that's going to be a plus 2x. Okay, the derivative of b is a constant and that will be 0. So plugging in 0, f prime of 0, that's just going to be a. So we now have everything we need. So L of x will now be equals to f of 0, that's b, plus f prime of 0, that's a, then multiply by x minus 0. And finally, that's just going to be b plus ax. L of x is the same as f of x, and f of x is the same as y, and y is the same as q. And this is our final answer. So therefore, the gradient m is equal to a, the intercept is equal to b, capital Y is equal to q, and capital X is equal to lowercase x. And this is the final answer to this problem. Hopefully you find this content helpful. If you haven't subscribed, like I said, please do subscribe to my channel. Thanks for watching. See you guys in the next video. By the way, if you have any question, feel free to let me know in the comment section below. And if you have anything to contribute to this video, always let me know in the comment section. Thanks for watching. See you guys in the next video. Bye for now.